Thank you. I'm not sure how I can follow the previous speakers. We're at the very early stages of something that we think could be a real game changer. But to give you just a snapshot of some of the things we've done. And before I forget, I think Dr. Patet suggested that I have 10 minutes, which I think means these awards are at least 5 times more important than the Oscars.
Yes, they are.
So I thank you, and I'm honored. What we're doing, my team has been investigating functional brain imaging for quite some time. We use the technique of magnetoencephalography, which measures the magnetic fields produced by neural activity in the brain, and we localize that. The problem is we can localize that in space, not relative to the brain, not relative to anything except the sensors. And so we need an MRI. Well, they're beautiful instruments. I'm sure most of you have seen an MRI instrument. They're beautiful instruments. They produce exquisite images. But you know what? As soon as you put the two together, you build in errors that are huge, much larger than any neurosurgeon would typically tolerate. So we thought that if you could possibly image the MRI together with the MEG and put them with the same instrument and put them together seamlessly without any co-registration, you eliminate that error. That's what got us into ultra-low field MRI. If you would switch to the next slide. I have very few, only 3 slides. The next slide shows some of the instrumentation that we've built. And in fact, our first instrument, supported very kindly by the NIH, is a 7-channel system that we showed one sponsor who, when we were presenting it to him, he commented it was the first time he had heard the words plywood and high-tech in the same sentence. But indeed, we were able to image with 3mm MRI slices both the MRI, which is the anatomy, and the function, the MEG, with the same instrument simultaneously and seamlessly integrated the two. I think that's pretty cool in and of itself, but I'd like you to imagine a system that can do MRI imaging with magnetic fields that are so small that a surgeon can hold a scalpel unperturbed in that magnetic field and actually cut while that image is being acquired. Imagine a system that 2 or 3 people can lift up. In fact, these systems that are shown here are 150 to 200 pounds, not the tons that a high-foot system weighs. Imagine a system that you can bring into the battlefield and detect TBI almost immediately after it possibly occurs. Imagine systems that you could find in every doctor's office and prevent a misdiagnosis, such as my father-in-law had, of a stroke. This is what I think ultra-low field brings potentially to the market, to the medical community. And while there's no doubt ultra-low field MRI will never reach the kinds of resolutions that high-field MRI does, they're really complementary. It does serve quite a role and impact, I think, medical imaging in ways that we're only beginning to imagine. And if you would go to the next slide. This work really could not have been possible. I'm standing up here representing a whole crew of people. This work is really representative of the diligence and dedication of students, postdocs, professors, and researchers from Los Alamos and elsewhere. And the couple you see on the right are an extraordinarily imaginative couple who are interested in bringing this technology to a location near you. Thank you.
Oops. See you do.